Question 39 looks quite similar to the last one, actually, doesn't it? So we'll start by looking at the vertical parts of this, because it starts at 18 meters a second. That's the J part of it. At its highest point, V, of course, is equal to 0. The acceleration is minus g, and we want to know when it gets there. So we're going to use a v squared equals u squared plus 2as again. So I've got 18 squared again. It is the same as the last one, isn't it? Very similar. Minus 2 times g times s. And so s is equal to 16.53 meters. Yeah, exactly the same as the last one. Okay, so for part B, we want to know how far it's travelled. Well, anytime we're doing how far it's travelled, of course, we start with the vertical again, because we want to know when it hits the ground. So we want to know when s is equal to 0, and how long does it take until it hits the ground. And so for this, I'm going to use an s equals ut plus a half at squared. We've got 0 equals 18t minus a half gt squared. Of course, one answers t equals 0 because that's when it starts on the ground. But the other answer from the quadratic there is the one we're going to want. And I'm getting 3.673 there. That's how long the journey takes. And so how far does it go in that time? Well, it starts at 23 meters per second and it keeps going at 23 meters per second. So if we just times these two things together, 23 times by 3.673, I've got 84.5 meters there. Just typing that in. Part C, just a little think. So part C, I'm actually going to use them as vectors now. And because when it's moving parallel, we're looking for when it's velocity. So I'm going to use a v equals u plus at formula here. And I'm going to use them as vectors. So the vector u was 2318. The vector a, of course, it's 0 for that part there, but minus g there, times by t. And so my velocity vector, let's move that up a bit, is 23 and 18 minus gt. And we want this to be parallel to the vector. So we want this parallel to the vector 2 minus 1. And what you do, if you want it parallel to that, we want some multiple on that. So 2 minus 1 times k. You can spot from the first bit, from the horizontal part, that 23 equals 2k. And so we can see that k is going to be 11.5. Stick the 11.5 in there, and we've got 18 minus gt equals minus 11.5. So just rearrange that, and we can get that t is 3.01 seconds.